class 10th, chapter Electricity, topic Ohm's law. This video is mainly about the kind of questions that can be asked from this particular topic. So let's start with the statement. When we start this chapter electricity, we are introduced to two physical quantities. One is current, which is the rate of flow of electron through any cross-sectional area, and the other is potential difference, which is the voltage required to make these electrons flow from one end to the other. Ohm's law tried to relate these two quantities. That is, how one quantity varies with the change in the other quantity. This is an experimental law and you do it as a part of your practical. The statement goes like this: the current flowing through a conductor is directly proportional to the potential difference applied across its ends, provided the physical condition remains constant. Now please note that I have highlighted the part about the physical condition because most of the time students forget to write this particular part and they end up losing half mark. So please remember, when you are writing the statement, there are two parts. The first part talks about the relation, that is the variation of current with potential difference, and the second part talks about the condition under which the law holds true. Now the second kind of question is about the mathematical form of Ohm's law, which is nothing new. It is just that we are writing now that statement in variable form. So as the statement goes, our current I is proportional to V. We can also rewrite it as V is proportional to I. Now you know that whenever we remove any proportionality sign, we get a constant, which in this case is represented by R and which is known as the resistance of the conductor. So this part of the question comes for 1 mark. After this, we are also asked about the circuit diagram to verify Ohm's law. That is also very simple. Now what all components are required for circuit diagram? We require a cell or a battery. Then we require a conductor, which is represented by PQ here. And since we have to find relation between V and I, so we need to measure them. For potential difference, we require a voltmeter, and for current, we require an ammeter. Now, since the current is same in series, so that's the reason we are connecting ammeter in series with the conductor. And since the voltage remains same in parallel combination, that is the reason the voltmeter is connected in parallel. We also attach a rheostat to vary the values. Since we have to perform the experiment, so we have to take a set of readings. So to vary the value, we have to change the resistance in the circuit so that the current and hence the potential difference changes. Now this can be done with the help of rheostat. You can also put a variable resistance in case of instead of rheostat. Or if you don't want to use rheostat or variable resistor, then you can also use a variable battery, which is shown in diagram C. The next kind of questions are based on the experimental values, wherein generally you are given a table which is having a set of observation and you are asked to find out which observation is wrong. Now these kind of questions are also very simple. What we generally do here is that you find out V by I ratio for each value. And whichever value is giving a different V by I ratio, which is nothing but your resistance, that value is wrong and you have to reject that value. And generally they ask you to find out the mean resistance after that. So you calculate the rejected value first and then you find out the mean of all the rest of the values. Next kind of questions are numericals based on the formula V is equal to IR, or you can also rewrite it as I is equal to V by R when you have to find out current, or when V and I are given but you have to find out resistance, then you can use the third formula, that is R is equal to V by I. For numericals, the steps to be followed will remain same which you use for any numerical in physics. That is, number 1, you have to write down the given quantities in the same system of units. Now, what do we mean by that? It means that suppose we are following SI system, or let us say, for example, I is in ampere, V should be in volt. If suppose I is in milliampere, so first we have to convert that into ampere. So we have to keep the system same. Second step is to write down the formula, and the third step is substituting the values and then do the calculation. And please don't forget to mention the unit in the result. One more important thing, you get marks for each step. So without worrying about calculations, just remember to follow each and every step. And the last kind of question which can come from this particular topic is the VI graph. Now, when you plot the values, experimental values of Ohm's law, we get a linear graph, that is a straight line. So, if we have to find out the slope of this graph, now slope is nothing but tan theta. So, tan theta is not new for you because you have already done trigonometry. So, how do we find out slope of this line or tan theta? We simply draw a right angled triangle here. Then the perpendicular upon base. Okay, that is, in this case, it is BC. Now, if you just extend this, so BC is nothing but variation in voltage, and AB is nothing but variation in current when the graph goes from A to C. So, tan theta is nothing but BC upon AB, that is delta V upon delta I, that is variation in voltage upon variation in current, which gives you resistance. So, please remember, when you calculate the slope of VI graph, it gives you resistance. Now, this question comes in the other form also. That is, if suppose instead of VI graph, it is IV graph, then what will change? Now, if I put I here and V here, then delta I, the variation in I will be in perpendicular and V will be in the base part. So, the slope will become I upon V. That is 1 upon resistance. So, slope of VI graph gives you resistance, but if it is IV graph, it will give you 1 upon resistance. Thank you.